welcome to another video. In this video, we are going to learn how to do the testing and programming of S7-1212 CPU. In this video, we are going to learn how to do the programming of S7-1200 CPU, and then after that we will do its programming and we will check its digital inputs and outputs, and after that we will check its analog inputs. So the agenda for our today's lecture is what is PLC. First we will discuss what is PLC, okay, why we use PLC in our industry. Then after that we will work on, you can say we will closely look into the CPU we are going to use in our whole video, okay, which is S7-1212c DC. Then we are going to do this wiring and programming. Then after that we will test its digital inputs and outputs, and we will test its analog inputs. So we will start our today's video. What is PLC? PLC stands for Programmable Logic Controller. What is PLC? PLC are, you can say, industrial computers. They have some central processing units. They can decide on the basis of a set of instructions we have given to it. On the basis of this set of instructions, our PLC control our different electromechanical processes, and this is how my PLC is doing automation in my industry. These are some of the benefits of my PLC. The benefits are: it is programmable, it is a plug and play, it is flexible. What does it mean by flexibility? In case of microcontroller, if you know that in case of microcontroller, if I want to use a microcontroller for a car wash system, and I cannot use same microcontroller for that for car parking system. Why? Because in case of microcontroller, I have to design PCB sheet for using microcontrollers. But in case of PLC, we don't need to do that. Okay. So in case of PLC, what we have to do, we just download the program of car parking system in it, and then I can use it for car parking system. If I download the program of car wash system in it, then I can use it for car wash system. My PLC is operational on 24-volt DC and on 220-volt AC bath. Its online monitoring is very good. Mostly we will work on TIA portal software. So in TIA portal software, we can design a program for a whole machine without even touching the hardware, and we can run it, debug it, and online monitor it. Okay. So next we will move on towards the CPU we are going to use in our today's lecture. So this is a CPU we are going to use in our today's lecture. This is S7-1212c DC. What does it mean by DC? First, DC is for input supply, that this PLC takes 24-volt DC as input supply voltage, and the second one is for input pins. The input pins are operational on 24-volt DC, and the third one is DC output pins. Its output pins are also DC. So now we will take a close look at the numbers I have stated, that what does these numbers mean. Okay, so we'll go to it and we will zoom in a little bit. So the first number is showing that here we will provide the 24-volt DC supply to our PLC to energize our PLC, and point number 2, my PLC is generating 24-volt DC, and it is giving it as output, and I can use that 24-volt DC with my inputs and outputs whether I want to use it. Okay, and the third pin is showing the input pins. This PLC has 8 digital input pins from 0 to 7, you can see here. So this means it has 8 digital input pins, and this point number 4 is showing about analog pins. So this PLC CPU S7-1212c DC has 2 analog input pins. This point number 5 is showing me an indication lights for run and stop mode, for error, and for maintenance mode. Okay, so through these indication lights I can check whether my PLC is on run mode or stop mode, or it has some errors or not. This point number 6. This point number 6 is for the programming part of PLC. For the programming of S7-1200 PLC, we use just simple lane wire for the programming of this PLC. You can see here, lane wire is used for the programming of S7-1200 PLC. And point number 7 is showing me the DC outputs, the digital outputs of my PLC. This PLC has 6 digital outputs from 0 to 5. Okay, and point number 8 is showing me the model of my CPU, which is S7-1212c DC. And these indication lights are for the digital inputs and digital outputs. The CPU, the model which I have to take in tier portal, select in tier portal is 212.183.00x V0. So now we will again move towards our. So now later in this video we will do is programming, and we will test its digital inputs and outputs. We will test its each digital inputs and outputs, and we after that we will test its analog inputs. Now I will open my TIA portal V13 for is testing. I have opened my TIA portal and I will name this project testing 7-1212c CPU. I will add a new device. I will choose S7-1212c DC 6 this one, and I will choose this frame version to 1.0. As you can see here, after creating a new project, I have added my PLC, which is S7-1200-1212c DC. Okay, and after that we will do its programming of this CPU. For that we will go to program block for testing its digital inputs and outputs. Now we will do the programming to testing its digital inputs and outputs. So in network 1 I will testing digital inputs and outputs, and in network 2 okay, I will add network 2 later. First I will comparison operators. I will take one comparison operator is equal to comparison operator, and I will use two move function blocks and one bit logic operation not in between these. So this is my program for testing its digital inputs and outputs. If any of the input is on, then my this block is working. Okay, and if any of the inputs is, you can say all the inputs are off, then my this block is working. At this block, what this block is doing, it is turning on my all the outputs. Okay, and if any of the input is on, then it will turn off my all the outputs. And now I will add another network. In this network we will check analog test analog inputs. First we will go to device configuration, and we will check the address of analog inputs of our this CPU. As you can see here, the address for channel 1 is, it has two analog inputs. The address for channel 1 is IW64, and for channel number 2 is IW66. Okay, so I will again go to main block, and I will take two blocks. You can take these normal X and scale X blocks from these conversion operators here, from here. Scale X and normal X blocks, I am taking it from here, but you can also take it from here. For the testing of first analog input, I have used these normal X and scale X blocks. The address of my first channel analog input, my first analog channel is IW64, so that's why I have used this pin here. Okay, then I have used this normal X blocks, and I am sending this normalized value to my scale X block. D70. Okay. I have just renamed the tag names. Analog input from channel number 1. This is my normalized value I am getting from my normal X blocks, and this is my scale value. I am giving normalized value as input to my scale X block, and I am getting my scale value. Now I will repeat that same process for my channel number 2. The address for channel number 2 is IW66. I have repeat that same process for analog input channel 2, IW66. Now I will compile it and check whether my program has errors or not. So it is showing me zero errors or zero warnings. Now I will download it to my device and check all the inputs and outputs, digital inputs and outputs, analog inputs of my program for testing digital inputs and outputs and for testing analog inputs. Now we will just download it to my PLC. For downloading it to my PLC, I have used LAN cable for downloading it to my device. Now I will just simply download it to my PLC. I will click on this button, simply load it, and downloading completing in my I have successfully downloaded my program into my PLC. Now I will turn on online monitoring. As you can see here, if my all the digital inputs are turned off, my all digital outputs are turned on. If any of my digital input is turned on, my all the digital outputs are turned off. This is the program I have written in ladder logic to test digital inputs and outputs of my PLC. Now we will check each digital input. As you can see here, when I have turned on my digital input 1, my all digital outputs are turned off. When I have turned on my digital input 2, my all digital outputs are turned off. Okay, so we have successfully tested it for digital inputs and outputs. Now we will do it for analog inputs. When I provide the pulse at analog input, you can see here my this value is varying. So this is how you can test your digital analog inputs. And for second analog input, if I provide the pulse 24 volt DC at this analog pin IW66, which is the address of channel 2, and this is the address of channel 1 analog input, first analog input, and this is for second analog input. Now we will see it from our PLC.